Okay, let's look at the number number 6 here, okay? Because we finished number 5 last virtual class with the number 6 right now, okay? Number 6. They said find the closest point of the curve x squared plus y squared equals 1 to the point 2 and 1, right? 2, 1. So for this one, you can general sketch let you think clearly. So when you have a function like this, that means what? That's a circle, right? That's a circle. And then you have a point 2 and 1. This is 1, huh? The radius is 1 here. We can see that. Center is 0. So 2 and 1, the point is here. This is 2 and 1. They ask you find the point on the circle. We don't know where's that point. We just say anywhere here. We call it as what? X and Y, right? So they ask you find this point, make the distance from here to here the shortest, right? So we can put this one as a D, okay? How do you find the D? D equals to distance formula. X minus 2 squared plus y minus 1 squared, okay? Now, they ask you, you need to find the closest point. It means you need to find the D is the minimum. This is D, eh? So we can set another one, just lowercase d equals what? X minus 2 squared plus y minus 1 squared, like this. To make this one minimum, that means this one minimum. If this one minimum, this one minimum. Okay, we just go by this instead of that. It's easier for us to do derivative. Okay, so we do d. I'll put this one as a different form, better way. So we go this one as what? We put it as y. No, this is not y. I already used the y already. So we use this one as z. Okay, z equals this one. The idea is this: to find this one minimum, you should have z minimum. If z is minimum, this is minimum, right? So we go dz d what? Dx. Okay? We find dz dx equals 0, right? So when you do this one, you can go like this. Derivative of this one equals what? Okay, so what we can do is what? Dz dx equals 0 to find what's the x, and then you can determine that will be the minimum, okay? But the thing is that this z is the function both x and y. So we have to what? Simplify first before we do any derivatives, okay? So we simplify now. We go like this. This one will be x squared minus 4x and plus 4. And then plus, this one is what? Y squared minus 2y plus 1, right? And then we know x squared plus y squared equals 1 here. So we can continue make this one equals to 1 minus 4x plus 4, right? And minus 2y plus 1, like this, huh? So we can continue make it as what? This is a 1, 1 is 2, this is a 4, this is 6, minus a 4x minus a 4y, right? And then we can get it from here. We can get it from here. Y squared equals what? 1 minus x squared, okay? And square root, so you got square root of that. And then we knew this one should be the first quadrant. So that y must be positive, right, on this side. So we can get what? We can get this one equals 6 minus 4x minus 4 times by square root 1 minus x squared, like this, right? Now, oh, this is 2, by the way, here. This is a 2y. So here, let me erase a little bit here. So this one should be, this one will be 2y. Yeah, hold on. So we have here, we just simply plug in y to here. So we got about 6 minus 4x minus 2y, right? So you got this one got to be 2 times by square root of 1 minus x squared. We got this now. Now we can do what? So because this is z, this is equal to z, because this one equals z. So we can do what? dz dx right now, okay? dz dx, so we do this right here. dz dx, this one equals 6, no more. This one just -4, right? This one just -4. So this here, -4. And then minus, and the -2, leave it here, okay? This part, you can write it as what? 1 minus x squared and half power. So you can put this one in front, power root, so you got 1/2, and 1 minus x squared and the -half power, and time by derivative of this will be -2x, but put parentheses, okay? So we have this one equals -4, right? Oh, -4, and this is -1. Oh no, this is -1, never mind. And then you have this one here. This is a -1, negative and negative is positive. This negative is positive, right? And then this is a 1 already. So you have what? 2x here. So you have here is 2x. But over this one, this part can put it down as square root 1 minus x squared. This one must be equal to 0, right? Because we make it what? Derivative equals 0 to find the critical point. So we have what? -4 put on the side. That would be 2x over square root 1 minus x squared equals 4, okay? And then you can have a 2x, oh, you just divide it by 2 easier. So make it smaller, the better, right? So we make this one as divided by 2, so you got to x equals to this one just 2 times by square root 1 minus x squared. And then both sides squared, so you got x squared equals 4, 1 minus x squared, like this, right? And then you distribute it in, so you got x squared equals 4 minus 4x squared. Move this on this side, you're gonna have what? You're gonna have 5x squared equals 4. So x squared equals to 4/5. So x will be equals to what? Square root 4/5, right? Square root 4/5, that will be equals to what? 2 over square root 5. So we find out, see here, x equals to 2 root 5. That's the critical point. You can plug in back to the original equation, right? The original equation x equals this one, right? Equals root 5. So we can get what? We can get, I put this x in, so you have what? 2 over root 5 squared, right? And the plus the y squared. Y squared equals 1, right? So this one you can get what? You can get 4. This one you can get 4 over 5 plus y squared equals 1. So y squared will be equals to 1 minus s is just 1/5. So y will be what? Square root 1/5. Square root 1/5 is 1 over root 5. Of course, generally we do square root, we have positive and negative, but here we just put as positive because we knew it should be in the first quadrant. So it's 1 over root 5. So we know this point will make the distance shortest to the point 2 and 1. One more thing is that when we do derivative, right? When we do derivative like this, equals 0, that's only the critical point. This is only critical point. Since this question, there is only one critical point, and we knew there is what? Only one position make the shortest distance, so we can consider as this is the minimum point there. Okay, and of course you can continue to do with the first derivative test for the minima, or second derivative test for the minima if the second derivative is available. Okay, so recall what we have here today is this. They just have what? The closest point on this graph is this, right? They ask you to find the closest point. So this is circle, this is the point. We assume the point is here, x and y. We don't know exactly x and y yet. And then we knew the distance is this. But generally, to make this distance minimum, you should have what? This z value minimum. Because it's under square root. If the under square root is minimum, the overall is minimum. So instead of doing derivative of this one to find the critical point, a better way to use this one. Easier. So we make derivative of 0. But the problem is that here we have x value and x variable, y variable there. So they have both two variables right now. But AP Calculus AB so far, we just cover single variable differentiation. So we have to do the substitution. We're using the given function of the circle. From there, we can solve the y equals this one. We're not pick up the y equals negative square root because we knew the point should be on the first quadrant here, okay? And then from there, we simplify this one first. We go to here, and then we go to here, and then we go to here. This is the z. And here the y, we substitute by that. So we simplify this z now. This is z here. After we find this z, we simply do the derivative. Use the power rule and the chain rule. And make the derivative of 0. And solve the equation. Of course, both sides square and solve it. We find what? The x coordinate of this point is 2 root 5. And then plug in this value back to this here. That's what we did here. We plug in, you can find the y. So then we find this point. So this is the point we're looking for. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.